Okay, so today we're going to move away from the two-dimensional shapes and move on to the 3D shapes. We're mostly going to spend today just identifying them and what a cross-section is. Next time we will start getting into their volumes. So first definition is a polyhedron. It's a 3D figure with faces that are polygons. To be a polygon, you have to have a straight side. So there's going to be no curves, no circles, nothing like that. All right, so the first one here that they have given to us is the edge. It says the edge is the line segment where two faces of a polyhedron intersect. So I'll highlight this so you can see an edge looks like that. That G to H, that's an edge. Moving to the right, we have a face. A face is a flat surface of a polyhedron. So now it's an entire surface. It's this whole plane over here, they're called. That whole thing is a face. A diagonal sounds like what it is a line segment whose endpoints are vertices that are neither adjacent nor on the same face. So it kind of goes from corner to corner here. And then the last definition is a vertex. It's where three or more faces of a polyhedron intersect. That's more like kind of just like this little corner here, like that point right there. So it's almost like you have a point, an edge, a face. You can see like these things get a little bit bigger, and this one has a special name, the diagonal. So that's just some vocabulary when you hear some of this come up in the definitions later. We're going to work with prisms and cylinders first. So prisms have two bases. Two is very, very important here. And those bases are polygons, again, has to have straight sides, and all the remaining faces are rectangles. This will make more sense when I show you one. A cylinder, it's very similar to a prism. They still have two bases, but this time they're circles. Remember, we can't have any circles or edges in prisms, so they just happen to have their own name. All right, so identify each type of prism or cylinder. Prisms are named by the shapes of their bases. Look for the shape that appears twice. Everything in this section has two bases, okay? All right, so let's look at the first one. So a lot of times the bases are like the bottom and the top, the front and the back, or the two sides. In this particular shape, it actually doesn't matter which ones you pick. So I'm just going to pick the one on the bottom here. It's looking like a parallelogram right now, but that's not what it is. It's actually a rectangle, because you can see that little right angle in the corner. It's just that it's angled to try to show the 3D shape on a two-dimensional sheet of paper. And you can tell it's a rectangle because it's 8 and 4, so two different sides. Okay, so I have a rectangle on the bottom, and in this like box-like shape, I would have that same rectangle on the top. So those are my two bases that are the same. So because the bases are rectangles, I would call this a rectangular prism. I'm not going to say cylinder because there's no circles or curved lines. All right, the next one. The next one on the bottom, I see what is looking like a rectangle again. However, I'm noticing that they both say 6, so that's not a rectangle, that's going to be a square. And that same square would be repeated on the top. Now, I would normally call that a square prism, which you could, it's not wrong. But these have a special type of name where not only is there a square on the bottom, but the height has the same dimension. We call that a cube, when all three dimensions are the same. All right, moving on to number 3. Again, I see on the bottom here a rectangle, but more specifically, it's a square because it says 3 and 3. Notice I have 2 bases again. It's the same on the top. This time though, I cannot call it a cube because there's a 7 here, not another 3. So this would just be called a square prism. Okay, rectangular prism, a rectangle on the bottom. Cube, all 3 sides the same. Square prism, a square on the bottom, but its height is different. Moving on to the next shape, what I see occurring twice are circles. Because it's a circle, I cannot call it a prism. When there's 2 circles, it's called a cylinder. This is like your soup can. All right, continuing on, again, I'm looking for things that appear twice. So I see in number 5 a triangle in the front. I see a triangle in the back. So I would call it a triangular prism. The other part of the prism definition that we haven't talked about, it says 2 bases that are polygons, there's your 2 bases, and remaining faces are rectangles. Notice I have rectangles, 1, 2, and the one on the bottom, 3. They're always going to be rectangles, the ones that aren't bases. All right, number 6, looking for the thing that repeats twice. There it is, along with this one. Those look like trapezoids to me. It's called a trapezoidal prism. All right, number 7. I see my 2 shapes that are the same. Those look like circles to me. The second I see 2 circles, I'm calling it a cylinder. So it's another cylinder. The cylinder just happens to be on its side. And then the last one for prisms and cylinders, looking for that shape that appears twice. Count how many sides that shape has. 1, 2, 3, 4, 5, 6. 6 sides is a hexagon. So hexagonal prism. Okay, so those are prisms and cylinders. You're going to see 2 bases that are the same with remaining faces that are rectangles. And if it's a cylinder, those 2 faces will be circles. All right, moving on. Now we're going to go on to pyramids and cones. So a pyramid, instead of having 2 bases, will have 1 polygonal base. Again, no curves, not for pyramids. And their edges will meet at a point. You're going to see like a vertex at the top. This time, remaining faces are no longer rectangles, they are now triangles. Cones are similar. It only has one base, but it's going to be circular. Edges are still meeting at a point. So you can see in the next 4 examples here, they all meet at a point up top. Could be a point at the bottom too, or the side, depending on how they're turned. But that's how you know you have a pyramid or a cone. They're coming to a point at the top. Now we're looking for only one base instead of 2. It's always opposite that point on the top. It's usually on the bottom. So I highlight the shape on opposite that point. Again, it looks like a parallelogram, but I see the right angle telling me it's a rectangle or square. Because they both say 5, I know it's a square. So we're gonna write square, and this is a pyramid. Okay, next one, the base is a circle. Can't call that a pyramid, that gets called a cone. Number 3, the base is a triangle. So triangular comes to a point, pyramid. And the last one, shape on the bottom. I see that right angle in there telling me it's a rectangle or a square. Because it's a 9 and a 4, it's a rectangle. So rectangular meets at a point, pyramid. So you can see the difference between the two. Prisms have a top and the bottom bases that are the same shape. Pyramids come to a point. Okay. Another 3-dimensional figure is a sphere. It's a round, solid figure. Okay. This is like your ball or the earth, something like that. Most people know what spheres are. So that's naming all the shapes. Now we're going to get into these things called cross sections, which are a little tricky to visualize. Sometimes the picture really helps you out. Sometimes it doesn't so much and you have to think. So a cross section. Cross section is a 2-dimensional shape that results from the intersection of a 3D solid and a plane. So you want to think about that you have this 3-dimensional shape and this like blade or sheet of paper is coming through and slicing it at different angles. So I'm going to show you the same shape getting sliced different ways. Okay. So here we have a cube. Right, all the edges are the same length. We learned what a cube was. And you can picture like a sheet of paper coming down through that shape vertically. And the shape here is nice and easy to see here. That shaded region looks like a rectangle. So the rectangle is the cross section that was created. Now, our plane or surface is coming in at an angle. This time, again, easy to see in this picture, this is a hexagon. And in the last one, if I come across horizontally, although it looks like a parallelogram, remember if it's a cube, the bottom here is like a square. So that's also a square up there. So this is the same shape that's been sliced at different angles, each producing a different cross section. Sometimes the cross sections will be the same depending on how you slice it. But that's what a cross section is. So let's show you another one with this shape being sliced multiple ways. So the next one's a cone, and this one, the shape is not as obvious to see. I'm gonna kind of show you how to like figure that out. So here comes this rectangle or this plane coming in to slice it. So picture this blade came down, sliced it, and now you have 2 pieces and you opened it up. Or what I like to do is I kind of trace where it hit that shape. For me now, it's kind of easy to see that the shape I would get out is a triangle. Okay, now we're coming in at an angle. I'm gonna try to, again, to like trace what's going on here. It's looking like I'm going to have a semicircle. Lastly, I'm coming in horizontally. So that's kind of cutting out this shape right here. That looks like a circle. So again, same three-dimensional figure getting sliced different ways, producing different types of cross sections. We will practice that a little bit. All right, like I said, some of these are easier to see than others. Identifying the shape resulting from each cross section. This one, here's my cross section. I can see it, it's visible, it's a triangle. So here's this plane coming through and slicing. Here is the shape in the middle that was made. That is a rectangle. Again, don't get tripped up on that it's at an angle. It's just the way that it has to be drawn. It's not a parallelogram. Next one, slicing down through this pyramid, I see this shape. That's a trapezoid. Number 4, when I cut through that pyramid, hard to see, but it's looking like I'm getting another triangle out. Okay, 4 more here. If I take a sphere and slice it, there's the circle that is formed. Now I'm slicing a cylinder. That looks like a rectangle to me. Slicing a cylinder again, but at a different angle, now I actually see a circle. And lastly, if I take this cone and slice it, I see a triangle. So that's it for what I'm going to do. The rest of this is to practice naming the cross section and just naming if it's a prism, cylinder, pyramid, or cone, or sphere. And that's it.